Welcome to Brain Vision.
Okay, so we know the mass flow rate can be equal to the area, the inlet area times the inlet velocity over the specific volume at the inlet, which can be expressed as pi times d1 over 2 to the power 2 times v1 and then over the specific volume. So we know d1 here is the diameter, which is 16 centimeter, which is equal to 0.16 meter. And we know the inlet velocity is 2.5 meter per second. And at 2 megapascal, 300 degrees Celsius, if you take a look at the superheated water table, which is table A6, you find that the corresponding specific volume is about 0.12551 meter cube per kilogram. So now let's plug in back to the equation to determine the mass flow rates. So the mass flow rate can be equal to pi times 0.16 meter divided by 2 to the power 2, and then times 2.5 meter per second, and then over 0.12551 meter cube per kilogram. And this will give us the mass flow rate is about 0.4005 kilogram per second. So now let's go to the next question. So for next question, well, we know the rate of energy transfer into the system should be equal to the rate of energy transfer out of the system, since the rate of internal energy, kinetic energy, and the potential energy is equal to 0. If we expand it, we have m dot h1 is equal to m dot h2 plus q dot r. M dot here is the mass flow rate, h1 is the initial enthalpy, h2 is the final enthalpy. And the q dot r is the rate of heat transfer out of the system. The reason why we use q dot r here, because as you can tell, the initial temperature is higher than the final temperature, which means that the heat from the system was losing. That's why the temperature dropped, okay? So if we do some arrangement here, we have q dot r is equal to m dot times h1 minus h2. And then if you take a look at the superheated water table, which is table A6. So at 2 megapascal, 300 degrees Celsius, the corresponding enthalpy is 3024.2 kilojoule per kilogram. And then at 1.8 megapascal, 250 degrees Celsius, the corresponding enthalpy is 2911.7 kilojoule per kilogram. And when the mass flow rate is 0.4005 kilogram per second. So now let's plug in back to the equation. So we have Q dot R is equal to 0.4005 kilogram per second, and then multiply by 3024.2 kilojoule per kilogram minus 2911.7 kilojoule per kilogram. And this will give us the rate of heat transfer is about 45.1 kilowatts, which is 45.1 kilojoule per second. And this is the answer for this question.